Good day everyone. In the last video, we saw formulae and concepts of chapter 5. Now let us see for chapter 6, that is application of differentiation. In this you have increasing and decreasing functions, you have tangents and normals, and maxima minima. Okay. Now first let us see increasing and decreasing functions. Just look at this graph. This is some function y is equal to f of x. If you see from this point to this point, the curve goes up, right? That is an increasing function. From B to C, if you look, it is just coming down. That is a decreasing function. Then again it goes up, again it comes down, like that. You have the increasing as well as the decreasing functions alternately. Okay. Now, mathematically, let us see what is the definition or how we have to find it out. If your f dash of x is greater than 0, you call the f of x is strictly increasing. The upward arrow I put for increasing, the downward arrow for decreasing. If f dash of x is greater than or equal to 0, you call it an increasing function. Similarly, if f dash of x is lesser than 0, f of x is strictly decreasing. If f dash of x is lesser than or equal to 0, it is decreasing. So these are all the conditions. These are all the concepts you should know. Then you should know the word monotonic. A curve f of x is said to be monotonic if it either increases or decreases in a particular interval. Okay, it should only increase or decrease, not that half of increasing and then decreasing like. So that is called monotonic. We will call monotonically increasing and monotonically decreasing, like that. So that you must know. Then in some sums, when you find your f dash of x, that may be a quadratic of the form ax squared plus bx plus c, which may involve some constant, and you have to find that value of the constant. For that, you should know two things. That is, if the expression ax squared plus bx plus c is greater than 0, two conditions are to be satisfied. One is a greater than 0 and d lesser than 0. D means discriminant, that is b squared minus 4ac. You remember, you have studied this in your 10th quadratic equation. D is b squared minus 4ac. If you want your ax squared plus bx plus c lesser than 0, then the two conditions are a lesser than 0 and d less than 0. So these things you require for doing some sums and finding the values of some constant. Now, when they give you trigonometric functions as f of x, your f of x may be like sin x plus cos x, sin x minus cos x, like that. If they give, normally they will give you some interval. Okay, maybe it is 0 to 2 pi or 0 to pi, like that. So within that interval, you have to divide it into sub-intervals, and then you will be finding whether in which interval your f of x will be increasing, in which interval your f of x will be decreasing. I can tell you one general algorithm to work out and find out the intervals in which a function is increasing or decreasing. That is, first when they give you f of x, you find f dash of x. Okay. After you find f dash of x, you equate that to 0. That will give you some values of x for which you will get your f dash of x 0. Then if it is an algebraic expression, if your f of x is an algebraic expression, you draw a number line like minus infinity to infinity, and in between you mark your x values. It may be 1, 2 or 3. So if you get two values, it will divide your number line into 3 intervals. Okay. Then in each interval, you have to take some point and find out the sine of f dash of x, right? You need not calculate the f dash of x. Keep it in the factorized form and find the sine of f dash of x, whether positive or negative. Then you have a tabular column, that is interval you have to write. Okay. Then sine of f dash of x, then nature of f of x. These are the columns you have to have. Now this first interval, you find the sign. If it is positive, then the f of x will be increasing. Then in the other interval, if it is negative, it will be decreasing. Like that, you have to find which are all the intervals in which the function will be increasing and which are the intervals in which it will be decreasing. Already I told you, if the given function is a trigonometric function, they would have given some values like 0 to 2 pi or something. In that interval, you find the subintervals and go with the same way. So this is about the increasing and decreasing, how to find the intervals in which a function is increasing or decreasing. Okay. Sometimes they may give some f of x and ask you it is neither increasing nor decreasing in a particular interval. That means in that interval, in one part it will be increasing and in the other part it will be decreasing. So if you prove like that, in the total interval it will be neither increasing nor decreasing. Okay. And if they want you to prove any function is just increasing in an interval or decreasing in an interval, don't equate your f dash of x to 0. You have to find your f dash of x and prove that f dash of x is positive for all the values in that interval. Similarly, your f dash of x should be negative in all the points in that interval if it is going to be a decreasing function. So, this is also something you should know. Now, let us move on to tangents and normals. Okay. You all know what is a tangent and what is a normal, right? That is, if you have any curve, you can take some point. If I take a point here and this line which touches it, that is called the tangent. It will touch the curve at one point. And if you draw a perpendicular there, that is called the normal. So, tangent is the line which touches the curve at one point and a normal is the line which is perpendicular to the tangent. Okay. So, here, first you should know how to find the slope of a tangent and a slope of a normal. You have a general formula. The slope of a tangent is dy by dx at x1 comma y1. That is important. It is not just dy by dx. Dy by dx is not the slope. Actually, only for a straight line, wherever you take, suppose you have a straight line, at all the points, the slope of the line will be same. Whereas, if you take a curve, at each point, the slope will vary. So, that point of contact of the tangent or the normal is very important. So, dy by dx at x1 comma y1, that is only called m, that is slope of the tangent. Then minus 1 by m, this is called the slope of the normal at the same point x1 comma y1. Now, when we talk about the straight line, I told you, the slope will be same in all the points. Here, you should know 2-3 ways of finding the slope. If they give you a straight line like this, ax plus by plus c is equal to 0, in such case, your dy by dx will be minus a by b. Or you can straight away differentiate and find out also. If the straight line is given of the format y is equal to mx plus c, this m, that is the coefficient of x, will be the slope of that straight line. Sometimes they may give 2 points on that line, the coordinates, like 1, 2, 5, 7, like that. If they give you 2 points, then the slope will be y2 minus y1 by x2 minus x1. You have studied all these things in your 11th standard coordinate geometry. Like, if they give you the angle which the line makes with the positive x-axis, that is theta, then your m will be equal to tan theta. See how many ways you have to find the slope of a straight line. If they give you the angle, it is tan theta. If they give you 2 points, it is y2 minus y1 by x2 minus x1. If they give you the equation of the format y is equal to mx plus c, the coefficient of x. If they give you the line of the format ax plus by plus c is equal to 0 minus a by b, or you can just differentiate it and find it out. So now you know how to find the slope of a tangent and how to find the slope of a normal for a straight line or for a given curve at a point x1, y1. Okay. Equation of the tangent at x1, y1. That is the next thing. Okay. If you want to find the equation of the tangent, it is the normal straight line equation. Y minus y1 is equal to m into x minus x1. This you have studied this in straight line, right? Y minus y1 is equal to m into x minus x1. This is the equation of the tangent. If it is the normal, you will have y minus y1 is equal to minus 1 by m into x minus x1. This is the equation of the tangent and of the normal at x1, y1. They may give the equation in parametric form. That is, they may give x is equal to some 80 squared or y is equal to 280, something like this. And they can give you t is equal to some pi by 4, and they may ask you to find the equation of the tangent at normal. In that case, find dx by dt, dy by dt. Then you know dy by dx is dy by dt divided by dx by dt. You will get dy by dx. Substitute t is equal to pi by 4. That becomes the slope, right? After that, you need x1, y1 in the formula. For that, in the x, you substitute t is equal to pi by 4. In y, you substitute t is equal to pi by 4. Then you will get x1 and y1, and then you find the equation of the tangent or normal. So, they may ask you to find the equation of the tangent and normal as a straight question, or they can give you the parametric equation and then they can ask you to find the equation of the tangent and normal. Okay. Next, if the tangent is parallel to x-axis, what is the condition? Dy by dx is equal to 0. If the tangent is parallel to y-axis, dy by dx is equal to infinity, you can say, or dx by dy is equal to 0. If the normal is parallel to x-axis, what does it mean? The normal is parallel to x-axis means the tangent will be parallel to y-axis, the other way, right? So, you can just reciprocate and take the results. Otherwise, wherever normal comes, you can convert it in terms of tangent and then you can use. These are the two basics you should know. If it is parallel to x-axis, what? If it is parallel to y-axis, then what you have to do? Then, if any two lines are parallel, it may be tangents, it may be normals, it may be tangent to another line, normal to another line. If any two lines are parallel, you know, the slopes are equal. So, m1 is equal to m2. Remember that concept. Similarly, if any two lines are perpendicular, then you know the product of the slopes that is m1 m2, that will be equal to minus 1, because this m1 m2 is equal to minus 1 we will use. They may ask you to prove two curves cut orthogonally. What is the meaning of cutting orthogonally? They are a triangle. How can two curves be a triangle? The tangents at the point of intersection are at right angles. So that we will use this concept m1 m2 is equal to minus 1. Okay. Then they may ask you to find the angle between two tangents at the point of intersection. Okay. Angle between two tangents at the point of intersection. That means you have a formula tan theta is equal to modulus m1 minus m2 by 1 plus m1 m2. We put a modulus because we want the acute angle, right? Then, if a tangent, see, now this is a curve and this is a tangent, right? Now, this is called the x-intercept and this is called the y-intercept. The tangent is making some x-intercept and some y-intercept. In some sums, they may say the x-intercept and y-intercept are equal. It is making equal intercepts on the coordinate axis. Then the concept is m is equal to plus or minus 1. Whether it is plus or minus, that depends on the quadrant where the straight line is there. Okay, so this is the concept. The same thing can be given using some other words. Now see this tangent, it will be making equal angle with the coordinate axis. You can call it they are equally inclined with the coordinate axis. Then also the concept is m is equal to plus or minus 1. Do you follow? The tangent is making equal intercepts with the coordinate axis, or the tangent is equally inclined with the coordinate axis. That means m is equal to plus or minus 1, and that is the concept you have to use. So, these points are clear to you. Next is maxima and minima. In that, actually there are two things: local maxima, local minima, and absolute maxima, absolute minima. First, let us see local maxima and local minima. There are three methods to find out the local maxima, local minima, and the maximum value, minimum value. First is without using derivative. This we will be using only in modulus sums. Okay. The concept is, if f of x is lesser than or equal to f of a, f attains maximum and the maximum value is f of a. If f of x is greater than or equal to f of a, f attains minimum and the minimum value is f of a. We have done sums using this modulus sums in the textbook and extra we have done, right? Then the second one is finding the local maxima minima using first derivative test. That is, we will be finding only one derivative, first derivative, and using that we will be finding. So, how we do that? F of x will be given. You will find f dash of x. You will equate it to 0 and you will find the x values for which your f dash of x is 0. It is something like your increasing decreasing only, right? Then after you find the x values, the same way, no, draw the number line. You will get minus infinity, infinity, and whatever points you get, and it will be in intervals. The same tabular column, what you do for your increasing, decreasing, you have to make here also. So, you will get here the interval, you will get the sign of f dash of x, you will get nature of f of x, right? So the same thing. So here let us just suppose it is minus infinity to minus 2 and you get it is increasing. That is the sign of f dash of x I will put positive. So here you get increasing. And let me choose the second one as minus 2 to 3. Here you get negative. So it is decreasing. Then I get 3 to infinity. Here I get a plus. So increasing. Just let us suppose I have just taken 3 subintervals. Now, if you see from here to here, from increasing to decreasing, right? The point, the common point is here minus 2. You imagine this curve, you remember? This is increasing, this is decreasing. At this point, you will get the local maxima, right? So, from increasing to decreasing means the common point is minus 2. So, at x is equal to minus 2, the f of x will attain maximum. Then, here if you see, from decreasing to increasing, decreasing to increasing. So, this common point 3, f will attain a minimum. Then you have to go to f of x, that is the original function. Substitute the value, that is this minus 2. You will get the maximum value. Substitute this 3 and you will get the minimum value. Let me tell you once again. In the first derivative test, find f dash of x. Equate it to 0. Then as you do in increasing, decreasing, have the tabular columns. And you find out the nature of f of x. Then you see, wherever it comes from increasing to decreasing, that means your f of x will attain a maximum. If it is from decreasing to increasing, f of x will attain a minimum. Find that common point, that will be the x value. Go to f of x, substitute and get the y value so that you can get the maximum value or the minimum value. Is it clear? Let us see the second derivative test. Find first f dash of x, equate it to 0, get the x values which are called the critical points or the turning points, right? Then find f double dash of x, that is the second derivative. Then at these critical points, how many ever you get for your x, no? You substitute them in your f double dash of x and find the sign of f double dash of x. If the f double dash of x is greater than 0, at that particular value of x, your f of x attains a minimum. If f double dash of x is lesser than 0, f attains a maximum. So, you know the x value. Go to the original f of x, substitute that x and you will be getting the maximum value or the minimum value. So, here the sign of f double dash decides whether it is maximum or minimum. This is called second derivative test, right? Then let us see about absolute maxima minima. What is absolute maxima and minima? You can have any number of local maximas and local minimas. Out of that, whichever is the maximum most, we call it as absolute maxima, and whichever is the minimum most, we call it as absolute minima. It is also called extrema or global maxima, global minima. Okay. So here you find f dash of x, equate it to 0, you get the critical points. In the sum itself, they will be giving you a closed bracket and 2 points. They are called end points. Go to your f of x, substitute the end points, substitute the critical points and find the value of f of x. Whichever is numerically the greatest value, that is the absolute maximum value, and whichever is the lowest or the least numerical value, that is called the absolute minimum value. That's all. So, I hope you are clear about the 3 ways of finding the local maxima minima and how to find the absolute maxima and minima. Then the thing left out is actually the statement sums, which may come as a case study sum, right? For that, you should know all the mensuration formulae which you studied in 10th, both for 2D as well as for 3D. Then actually the case study sum, once you understand the sum, that itself will lead you, because when you solve the first subdivision, the second will come from the first, like that, it will lead you. So you can properly read the sum, understand it, and then you can proceed with it, because there is nothing special about it. Read all the mensuration formulae thoroughly, and then if from maxima minima you use it. Sometimes you may get case study sums from other chapters also. So I hope now you are okay with all the formulae and concepts in chapter 5 and chapter 6 thoroughly. Please tell me in the comment section whether this is useful for you, so that I will try to do whatever possible by tomorrow afternoon, so that you can work it out on the remaining 2 days before the max exam. Thanks for watching the video.